When you start talking about servers, I think hard drives start becoming a very important topic. Because in your normal system, you've got one disk, right? As a single user, just yourself, this guy can serve up everything you need. You know, if you're working hard, you know you're working hard. But with one user, it can keep up with you fairly well. But when we start adding multiple servers, that's handle your requests and their requests, or multiple users, has to handle their requests, and all of a sudden, this disk, it's working really hard, can't keep up with all the requests across all these users. So not only is the speed of this guy split, let's just say this thing runs at 80 megasecond, each of these guys gets 20. Well, let's, add on a few more to these guys and these guys and these guys. Now we're talking like 10 meg a second on max throughput speed. And the reality is that because it's trying to serve all of these users, it can't stream the data. So these transfer speeds is when you're streaming large amounts of data towards the user. When you've got to grab just a single file from here and there, it totally works the hard drive in a way that it can't respond. So what we have is, we have a spinning platter, right? Your bits are going around and around, and it's got to find, with its little read head, it's got to get your bit underneath this to serve the request, right? If all your bits are in a row on the disk, it can just read right through them and stream this data off very, very fast. But when the pieces it needs are all over, it's pulling this bit, get to this bit, get to this bit, get to this bit, get to this bit. And that's where this random access really tears the drive apart. So there's a couple ways to solve this issue. One is we add more disks, right? We have more disks in the stack. We have more of them serving our requests. And that's the first thing servers do, is they add more disks to increase the number of IOPS, instructions, internal operations per second, so that they can serve more workloads. And by doing this, we can also stream off all three of these. So instead of getting just 80 a second, we get like 240 megasecond top speeds. Right. And this is when we're just saying, let's just give me large chunks of data and we will stream it as far and as fast as we can go with it. But we're also we also got to talk about the speed of the disk itself, right? How fast, is it spinning? Because we have a couple of different flavors of disks. We've got your 72, let me check that. 72,000 RPM, rotations per minute. This is probably, when you buy a consumer desktop disk, this is what you're getting. It's a SATA drive, serial ATA, and it's spinning about this fast. when you move into server storage, we get 10,000 RPMs, 15,000 RPMs, and we also have solid-state disks that are enterprise level. And let's classify all these as SAS, serial attached storage. Is that right? That sounds right. Now, we can get these guys in a nearline SAS, but I'll come back to that later. And one key difference, though, is the sizes of these things. Where I can get one of these drives here close to, say, 4 terabytes. This guy here would be like 200 gig. You know, this guy here would probably get about, let's just say 600 gig at a reasonable price, and this guy here about 900 gig. For this guy here. So, as the speeds increase, the amount that we can store on a disk decreases, because I think they've got platters are just spinning that much faster that they can't reliably read the higher densities that we see on these slower disks, because it's just moving too fast to read them. So speeds become a very important factor when you're looking at server disks, because while this guy here could probably get 80 megasecond, this guy here is probably pushing like 500 megasecond. 1500 RPM, I think that's what, like 180 to 220 meg. I'll probably put this guy here at I'll say 120 meg second. So because they're spinning faster, they can move more data off their platters at with significant speed. And we start talking about IOPS, which is a very important factor. This guy here, he gets like 80 IOPS. This guy, say 20 IOPS, and this guy here like 180 IOPS, and this guy here like 20,000 IOPS. Kind of ridiculous, but as you move into enterprise storage, all of a sudden we start thinking about our disk in terms of operations per second, more so than through output, because there's so many different sources of accessing the disks that it's going to be considered random, right? Random I/O, and these IOPS are going to matter.